Welcome to the next video discussion for the lab project adding I/O modules that was on pages 25 through 37 approximately, volume 1 of an introduction to RS 5000. Okay, welcome back. This is the next section, adding I/O modules to your data neighborhood. That's the lab project you should have just completed. So basically we're going to work with the I/O configuration tree, and right here it is at the bottom of our Project Explorer controller organizer. Think of the I/O configuration tree as a virtual electrical structure. This data pathway is the only map by which the processor can access the data neighborhood, and you will learn this as you get more involved with the Logix engine. If you don't create the path, if you want to do producer-consumer tags with other processors on the network, if you don't add those processors into your I/O configuration, you're not going to communicate with them producer-consumer. Now I know I just introduced a subject that we're not going to go into, but just tuck that away, producer-consumer. Very good stuff. It is a list of hardware objects assigned to the processor's team. All processors have at least 2 physical ports to the outside world. In the old days, they were all on the front of the processor. The connector on the back really was not considered a port, even though it did interface with the I/O modules. It really wasn't communications. It was one slot at a time activation, thereby called active backplane. We have a whole video or two, probably 4 or 5 different videos that go over active backplanes in our stable. So you might want to go watch those if you want more information on active backplanes. So with the compact Logix, there may be one or more on the front of the processor and maybe on the back connecting it to the backplane. Control Logix typically has an RS-232 9-pin sub-D shell on the front. Now they also have USB on the front. But up until recently it was just RS-232 on the front and then control bus port on the back. So the connector on the back of a processor in this platform is a communications port to the backplane, because the backplane is a network, at least for 1756 chassis and 1756 processors. The 1769 processors have all of their COM ports on the front, with the exception of the 1768 processors. So the 69 have all their COM ports on the front, whereas the 1768 compact Logix has one on the front and one on the back. The exception to this rule are the L1, L2, L3 processors, the newer ones, which have a USB port on the front and 2 Ethernet ports, but 1 IP. So it's basically is a hub, I guess you could say, but you can plug 2 Ethernet cables into it, so you don't need to go to a hub or a switch. You can daisy chain. So the new L1, L2, L3 have a USB on the front and then 2 Ethernet ports, 1 IP on the front bottom edge. And I think they might be changing that format. So they're not on the bottom edge, but they are more easily accessible at an angle. I'm just guessing that's where they're going. Okay, digital DC input module. With your L35E project open in RS Logix 5000, the one you just created, let's add some I/O modules. The controller has a single active backplane. Looking at the I/O tree, you might think there are 2 places to add modules. So if we go right to backplane and right click, that's grayed out. See? No new module, no discover modules. Okay, if we go down to this compact bus local, right click, now we can select new module. So we select new module. And I see some of this is going outside of our frame, so I'll move it in. The older versions, this is version 20. Version 17 doesn't look like this, but it still does the same thing. Here we can uncheck all of those filters and then recheck just the ones we want. We want digital, we want Allen Bradley. Okay? Now, we didn't need to do all that because we still could have found our modules. Once we've done that, because that's what I had you do in the manual, mainly just to demonstrate how you set the filters. We want to go down to an IQ16F. That is the particular input module that I have available to me right this moment. We're going to select this and then click on Create. We're going to name it, and we're going to call it something real clever like DC underscore in for input, and it's in slot 2 in my application. So you could put 0, 2, or just 2. Now the reason I do this is because later on when this pops up, you see DC, you know it's digital, and you see in, you know it's digital inputs, and 2, you know it's in slot 2. So if you're not anywhere near the hardware, matter of fact, you don't even have the I/O tree to look at, and you probably can't picture the reason or the scenario for that right now, but believe me, it will happen as you get deeper and deeper into the learning process and using this platform. You could be on another processor that accesses data from this one, and when you see that particular designation, then you know it's a DC input card in slot 2 of that other processor that you're accessing from some remote processor. So anyway, now notice it says slot 1 over here, so I have to slot it. So I say name it, slot it, then I go to change here. I disable the keying, electronic keying. In the old days, keying literally was a key. In each I/O module, each separate part number had a notch, a little slot cut into its circuit card edge that slid into the connector on the back plane in the chassis, and that notch was at a different location for each individual module. So when you bought the module, it came with these little plastic keys, and you reached back there into that slot and you placed it in the right position so only that part number module could slide in there. That was called keying. Well, we don't do that anymore. So now our choices are exact match, meaning the part number and the revision levels have to match. So exact match means that your module would have to be revision 3, subrevision 1. Compatible module, only the major revision matters, this one doesn't. I disable keying for the labs just so we don't have to deal with it. Okay. Now this particular module is nothing special, so your only connection is input, and your only data format is integer. Some of the more advanced modules, more expensive ones, especially 1756 I/O, you have some choices here beyond what you see here. Now there's also a series, and for this module there is only one series, and there is only one revision level. So all I changed was disable keying in this case. Okay, so I did all the changes. Now I'm going to say OK. Now I'm going to close this for a moment because I want to point out something. Notice now, we'll click up here just so this isn't highlighted. Notice the compact bus local now has a module listed in slot 2. Also, remember the module defined, there was nothing there. There was no plus sign. Now there is. These two tag structures, data structures, support that input module down there. I'm going to collapse this so we can see down here. This module requires these two data structures, one for I input and one for C configuration. If we double click on these, we can see the data structure for that particular tag structure. We have a double integer, that's 32-bit word, and then we have an integer which is 16-bit. They're both binary and they're both read-write. That's all there is in that tag structure. But it also needs a configuration tag. And in the configuration tag you have considerably more. You can set filters. Maybe we'll get into that, maybe we won't. So I'm going to cancel that. But I just want to show you that now you have some module defined tags because we added this card. if you were to delete this card, those templates would stay. They don't support anything, but once they're exposed, they're there. Now, if you export this project, it will clean up any unused things, data things, from the project, and these would disappear. In a later lab, I'm going to have you add I/O modules simply so you can create tags using these tag structures, but they're not, the tags you're creating aren't really I/O modules, but they're using that data structure. Close that up there, collapse that. By the way, if you want to see what the rev level is on a module, you can go to RS Links. See if we can get that back up here. There it is. Go to RS Who, expand, expand, expand. Okay, we'll right click on the processor, device properties. Whoop. Right there. Sorry about that. Okay. Remember I told you that was a placeholder. I right clicked on it and nothing happened. It's up here, not here. That's just there to show you what's in slot 0. That, electrically or data-wise, is the processor. Okay, so here's what you got. 1769L35E, version A, Logix 5335E, AB company, blah, blah, blah. Revision, the firmware in the processor is flashed to 20.012. The serial number for that processor, and the EDS file identification. Minor recoverable fault, that's probably the battery. Anyway, batteries aren't a big deal for us for course development and training because we're not actually running a machine that has to have a good battery to back up the project. So, now let's expand our bus here, because remember we didn't have anything here before. Now look what we've got. Now I didn't, oh, you know what? I know why I didn't open this up before. I didn't want you to see all this because I haven't added all this in yet. So I haven't added all of these modules in, but in RS Links it still sees them. So there's our IQ 16F. Right click, device properties. See, Rev 3.001. If I go to this OB16P, right click, device properties, Rev 3.001. Go to my analog card, device properties, Rev 1.001. So, if you're ever wondering what the rev levels are, the firmware revision levels of your hardware, just go to RS Links, drill down, expand, 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 right click properties, and you got it. So we'll close that up and go back to RS Logix 5000. Now let's add a digital DC output module. So it's the same process. Right click on the compact bus local, new module. We'll move this up here where you can see the whole thing. Now, I showed you one way to narrow the search by putting in filters. Typically, since I know that this is an OB16, I just type in OB. See how much simpler that is? We could have typed in IQ. You see how the filter is adjusted? It's type forward, so to speak. You know, it's thinking for you. You type in O, let's back up one letter. See, that expands. See, now all the filters, everything is selected. We could have typed in IQ earlier, and there's your IQ 16F. If we would have typed in, we'll try 16F, it'll come right up with it. Knowing how to get it to just pop up as one choice, that's really irrelevant. So we type in OB, and we want a 1769 OB16P. So I could click here and click create. I'm just going to double click. Okay, and we're going to call this puppy DC underscore OUT01. So DC card output slot 1. We already got slot 1 picked. Notice that slot 2 is not available because you already got something in slot 2. Very friendly software. Change, we know that's a 3.1 because we just went and looked, right? However, I'm going to disable the keying anyways. Good practice for labs. Changes will cause module data types and properties to change. Remember, I'm changing the rev level. With each new rev level, it's either improving something or adding additional features. Changing a rev level on a module does have some criteria behind it. Now in this case, we're putting it in fresh. It doesn't matter. So we'll change the module definition, and then we click OK, and there we have it. We'll close that box, and we'll collapse. Whoops. Let's see. We'll collapse this. That gets our whole I/O tree in the picture. So there's the OB16P we just added in slot 1, and there's the IQ16F in slot 2. Back to module defined data types. Remember, there was 2 of them there when we last looked. Now we added another module, and looky here. It requires 3 separate tags to support it. And here's the most interesting one. This is an output module, right? See? DI, digital input. Okay? These are DO, digital output. But looky here. There's an I there. So O for output, I for input, C for configuration. This was the support of that input module, input, and this supported that input module. C for configuration, C, IQ16F. Now it puts these in alphabetical order. That's why the 2 that support the digital input card are split up with these in the middle. By the way, the most important tag for input modules is the one called data, and I did not point that out. So I'll go back here. This is back for the input card. See right there, data? Those are your 16 inputs, 1 integer. And here, output, data. Those are the 16 bits for your outputs. Now, inputs. For this particular output card, you have data coming back from it. It's an output card. Your memory locations addressed by your logic for the outputs, they influence the actual hardware outputs in this module. But this module sends data back. It sends back fault, and it sends back readback. We won't go into how to use those right now. I just wanted to point that out. So if you're ever wondering what these module defined tags are, you should not only know now, you should be able to impress your wife, your kids, grandma, grandpa, and everybody you know by giving them a short lecture on module defined data types. You might even get a free cup of coffee at Steak and Shake by giving the waitress or waiter a lecture on module defined data types. Just joking. Okay, so module defined data types, we've covered that. Now, I/O in your controller tag database. Remember before we opened up program tags, nothing. Okay, it's empty. Now we'll go to controller tags right there. Remember, it was empty before. Look at that. And here's what I want you to notice. Looky there. Do you recognize those? I'll give you a hint. Ooh, looky there. Now, here they're in the order of slot number. Local, chassis, local backplane, slot 1. Local backplane, slot 2. Configuration, input, output. Configuration, input. Because remember, the output card does have some inputs in the sense you have information coming back. Here are the data types. There they are right there, module defined. You're an expert now, folks. By golly, if you can't get a high-paying job, free soda pop at the local pub, I'd be surprised. In the lab, you know, I go through this in detail. It's much easier to do it on the screen here with a pointer and speaking than it is in screen captures. And I actually had you open the template in the lab, and I had you open the actual tags that you just created. So remember, this one right here, local, no, local 1C, local slot 1 configuration is an instance of DO16C0. Right there. See? AB 1769 DO16C0. Right here. So this is an instance of that data type. It's like this is dog and this is German Shepherd. All German Shepherds are dogs, but not all dogs are German Shepherds. Dog is a class of objects called dogs. Everybody knows what a dog is. But when you say dog and you don't say anything else, well, everybody immediately thinks, okay, got fur, got a tail, maybe, or not much of one, got ears, maybe somebody trimmed them like a Doberman pincer, got a nose, got 4 legs, got paws, and it doesn't sweat, it pants with its tongue to get rid of body heat, etc., etc., etc. So when I say dog, everybody thinks, if you've only ever seen one dog in your whole life, and it's a Chihuahua, well then if I say dog, you see Chihuahua. But really, dog is the class of objects. Chihuahua is an instance of the class. I hope this is all clear to you. This is really, really major in RSLogix 5000, the Logix engine, is understanding the tag database. The tag databases are what kicks everybody's butt in 5000. You know, grab a hold of this, wrap your mind around it, chew on it, meditate on it, think about it over and over again until you got it nailed. Okay, let's see if there's anything else here worth mentioning. So in the lab, I say continue correlating the modules in the I/O tree with the controller tags and data types until you are comfortable with the association. This is one of the single most important characteristics of the Logix engine. If you don't get this, you will not do well with RSLogix 5000. Okay, we're going to stop here in this presentation and then continue on in another. This has gone way too long, almost 23 minutes. Thank you for watching this video discussion of the lab project Adding I/O Modules.